Okay, in this video, we're going to continue our conversation about naming chemical compounds. But this section is going to cover how to name binary molecular compounds. So remember, the first thing you have to do when naming a compound, whether going from symbol to word or word to symbol, is determine what the elements are in your compound, whether they're metals, nonmetals, transition metals, or polyatomics. So when we have a binary molecular compound is when I have a nonmetal bonded to a nonmetal, which is going to mean that I have a covalent bond, meaning that my elements are sharing electrons in order to form that bond. Okay, and since I'm sharing electrons, I need to use prefixes to communicate how many of each element I have in my compound. And so my prefixes, remember, I have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So these are all the prefixes that I'm going to use to communicate the number of elements I have, or the number of each element I have in my compound. So when I'm writing my names, just keep this in mind. The element with the lower group number on the periodic table, so the one that's farther left, is going to come first. So on my periodic table, phosphorus has a group number of 15, while oxygen has a group number of 16. So phosphorus has the lower group number. It's farther to the left. It's to the left of oxygen, so it comes first. If the elements are in the same group, then it's the one with the greater period number, or the one that is farther down in that group, the one that's farther down in the periodic table, that comes first. And then our compound is going to end in "ide." So let's look at P2O5. So P2, I have 2 phosphorus, so I have to use the prefix di. And then I'm just going to name my element. Diphosphorus. And I have 5 oxygen, so I'm going to use the prefix penta. And instead of doing pentaoxide, I want to try to minimize my number of vowels. So it's actually going to be pentox, and then remember it ends in "ide. Pentoxide. My SO2, I only have 1 S, so we might think that it would be monosulfur, but when I only have 1 element as my first element in the compound, I can actually drop that mono. So this is just going to be sulfur dioxide. Di for my 2, ox for my oxygen, and then it has to end in "ide." So down here, my P4O10, I have 4 phosphorus, so it's going to be tetraphosphorus. And I have 10 oxygen, so decoxide. Okay, so that's how I can go from symbol to name. Now let's take a look at how I go from name to symbol. So silicon tetrachloride. I know silicon, since I can drop the mono, I know I just have 1 silicone, and tetrachloride. So chloride is chlorine, because remember everything ends in "ide. And if I have tetra, then I must have 4 of them. So my little subscript 4 tells me that I have 4 chlorines. Down here, my krypton difluoride, I just have 1 krypton, and di is 2, and fluoride is fluorine, so F2. Here, my tetraarsenic decoxide, ooh, that's a mouthful. My tetra means 4. My arsenic is AS, and I've got 4 of those because tetra is my prefix that means 4. And decoxide, deca meaning 10, oxygen, is the oxide, and I have 10 of those. So I have As4O10 for tetraarsenic decoxide. So remember, when using binary molecular compounds, you have a nonmetal bonded to a nonmetal with a covalent bond, meaning I'm sharing the electrons between my nonmetals. I'm going to use my prefixes over here to tell how many of each element I have in my compound. And if you need to construct this from scratch, your element with the lower group number comes first, or if they're in the same group, the element with the greater period number comes first, and then your compound ends in "ide." And that's it. That's all you need to do for naming binary molecular compounds.